Hello students, how are you? I hope you are doing well. Today I have come up with a new video. This time I am going to discuss 25th January, the morning session JEE Mains 2023. I have picked three questions. All the three are from modern physics. Let us discuss them one by one. So here comes the first question. Electron being used in an electron microscope when accelerated by a voltage of 20 kilovolt has a de Broglie wavelength of lambda naught. If the voltage is increased to 40 kilovolt, then the de Broglie wavelength associated with the electron beam will be. So here the question is based on de Broglie wavelength. As we know that de Broglie wavelength, formula for de Broglie wavelength is this. Formula for de Broglie wavelength is h by p, where p is the momentum. Whereas here we don't have any idea about momentum, rather we have idea about the acceleration voltage. Acceleration voltage. So we know charged particles can be accelerated through a certain potential difference. And when they are accelerated, they gain kinetic energy because work is done by the electric field on them. So in that case, we can convert this momentum into kinetic energy, and kinetic energy is this under root 2 mk. Further, the kinetic energy gained can be written as charge multiplied by accelerating voltage. Is it? So here you can see that h remains constant, mass remains constant, and charge remains constant, because after all it is the same electron which is being accelerated in the two cases. The only change is in voltage. So I can write here lambda varies inversely as square root of accelerating voltage. Okay. So now let us find the factor of change. See students, the way I am solving, you are also supposed to solve in the same manner. I am calculating the factor of change. Factor of change for lambda. Factor of change for lambda will be 1 by under root. Just substitute the factor of change of voltage. What is the factor of change of voltage here? How to calculate the factor of change? Factor of change is nothing but the final value divided by initial value. The ratio of final to initial value is known as factor of change. So here factor of change is 40 kilovolt upon 20 kilovolt, that is 2. So I'll put it 2 here. So factor of change of lambda is this. That means the new lambda is original lambda into factor of change. So correct option is the fourth option. Okay. Then let us move to the next question. The next question is this: the ratio of the density of nucleus, oxygen nucleus, and helium nucleus is. Students, you must be knowing that nuclear density is a constant. It is independent of the nature of the element. We can get that very easily. So how to calculate density? Density of anything is given by mass upon volume. Now, for a nucleus, assuming a nucleus to be a sphere, it has nucleons, and number of nucleons is nothing but the mass number. So if mass of each nucleon is AMU, so 1 AMU into A will be the total mass of all the nucleons, that is the nucleus as a whole. Volume, you can substitute 4 by 3 pi r cube. So this will be 3 AMU into A upon 4 pi. Radius is actually a constant into cube root of mass number. This is an empirical formula, you all must be knowing this. Empirical formula for the nuclear radius of any element. Now you can see that the mass number gets cancelled here, ending up with a constant. Okay. So regardless of the nature of the element, the nuclear density is a constant. Remember this. Then coming to the third question, the wavelength of the radiation emitted is lambda naught when an electron jumps from the second excited state to the first excited state of hydrogen atom. If the electron jumps from the third excited state to the second orbit of the hydrogen atom, the wavelength of the radiation emitted will be. Students, a small piece of advice, you have to be very, very cautious regarding the term excited state and orbit. For an hydrogen atom, the ground state corresponds to n equal to 1. Ground states corresponds to n equal to 1. So, and the first excited state corresponds to n equal to 2. Second excited state corresponds to n equal to 3, and so on. So this is the first excited state. The electron resides here. The second excited state, it resides in the n equal to third orbit. In the third excited state, it is at n equal to 4, and so on. Right. So now moving on to this, when an electron jumps from the second excited state to the first excited state. First excited state. That means this transition. Now you know that energy radiated is nothing but the difference in energy between the corresponding orbits. Now for a hydrogen atom, it is 13.6 electron volt multiplied by 1 upon the lower orbit in which it comes upon n of the higher orbit from which it drops. This is L, this is H, lower orbit and higher orbit. And this energy is nothing but hc by lambda, because we have to calculate in terms of wavelength, lambda. Okay. So here what I can say is this. This will come here. So finally I can write 1 by lambda varies inversely as 1 upon n low square minus n high square. So in the first transition, the transition is taking place from n equal to 3 to 2. 3 to 2. So I can write 1 by lambda naught is equal to some constant into 1 by 2 square minus 1 by 3 square, which is k times of 9 minus 4 is 5. Then the second transition is from where to where, you can see it is from the third excited state to the second orbit. So third excited state means what? N equal to 4 to the second orbit. This 4 to 3. Second orbit, I'm sorry. Second orbit means this. 4 to 4 to 1, n equal to 4 to n equal to 1. So 1 by lambda, lambda is the value which we have to find. I have taken this as lambda. 1 by 2 square minus 1 by 4 square. So k into this is 16 can be taken as the LCM. 4 minus 1, that is 3. So dividing 1 by 2, you have lambda by lambda naught is equal to 5 by 4 into 9 to 16 by 3. Remember, k gets cancelled here. So 4 fours are, so this is finally we are getting 20 by 27. This lambda naught goes up. So x is 27. Okay. Lambda is equal to 20 by 27 into lambda naught. So x is 27. Moving on to the next question. Sorry, we have only 3 questions here. So that's all in this video. I hope you like my way of teaching. Please subscribe to my channel and hit the like button. Also share with your friends and relatives. Thank you so much.